Hey guys, welcome back to my CCNA 200-301 course. Patrice is here, and in this video we are going to review IP version 6. Are you ready? Let's get started. The main reason that Yana needed a new version of IP was IP version 4 exhaustion. By the early 1990s and introduction of e-commerce, the need for IP version 4 increased significantly. So they needed to think about a new thing, and they had to find a short-term solution as well as a long-term one. And finally, for the short-term solution, they introduced CIDR and NAT, and for long-term solution, they selected IP version 6. You may ask, what happened to IP version 5? Was there any IP version 5? Yes. The IP version 5 has introduced but has never adopted as a standard protocol. Let's review some key facts about IP version 6. Each IP version 6 address is 128 bits. So the whole address space would be 2 to the power of 128, which equals 3.4 to 10 to the power of 38, which is a big number. In IP version 6, no classes has been defined, so we don't have class A, B, C, D, E like IP version 4. In IP version 6, we use subnet mask with the same application and same concepts, but the name has been changed to prefix. And finally, the only way we can show IP version 6 addresses is prefix notation. So we just write down the IP address / the number of subnet mask or prefix bits. That's it. This is how we present an IP version 6 address. As you can see, there are different parts that have been separated by a colon. Each part is called a quartet. As you can see in the slide, the basis that we use for presenting an IP version 6 address is not decimal like IP version 4, but it is hexadecimal. Since it is hexadecimal, we are able to use numbers from 0 to 9 and characters from A to F. And each quartet equals 16 bits. So in total, we'll be having 8 quartets. There are some abbreviation rules that we can use to write down an IP version 6 address a bit shorter. First, you can remove leading zeros in a quartet. Second, you can replace all zeros quartets with 1 zero only. And the third one is you can replace consecutive all zeros quartets with double colons, but you can do it only for one occurrence. So for example, for this IP address, you can write it down or abbreviate it like these three. All of them are correct, but definitely the last one is the shortest one. But you cannot write it down like the last one because it is not possible. Just like IP version 4, each IP version 6 address is logically divided in two different parts, network ID and host ID, but the names have been changed in IP version 6. Network ID has been changed to prefix and host ID changed to host. IP version 6 also has different address types or messages. The first one is Unicast addresses. Unicast addresses are just like IP version 4, unique IP addresses that we assign to our hosts, and they can use it to send one-to-one messages. Unicast addresses themselves have different types. The first one is global unicast addresses, which are like IP version 4 public IP addresses, and they are routable via internet routers, and the range is 2000/3. The next type is called unique local addresses. Unique local addresses are just like private IP version 4 addresses that we use them inside our LANs without any conflict with internet, and the range is FD00/8. And finally, link local addresses. Link local addresses are the addresses that are assigned automatically to your hosts as soon as you enable IP version 6 stack on the host. This address is only usable inside your networks, and they cannot go beyond the routers. And the range is FE80/10. The next address type is multicast addresses. Just like IP version 4, we use multicast addresses to send a message to multiple hosts at the same time. And the range of multicast addresses in IP version 6 is FF00/8. We don't have broadcast addresses in IP version 6. And in some circumstances, we can use multicast addresses instead of broadcast addresses for some purposes. And finally, Anycast addresses. Anycast addresses have been introduced in IP version 6, and we don't have the same type of addresses in IP version 4. With Anycast addresses, basically, we can assign a single Anycast address on multiple hosts. And the devices will send the packets destined to that common Anycast address to the closest host that has that specific Anycast address. How we can benefit from this? For example, we can set this IP address or set this Anycast address on multiple routers in our network. And then our computers, for example, or any host that need to go beyond these routers, will select the closest router to reach out the outside network. In this way, we can do load balancing in our networks. I'll show you in next videos how we can set up Anycast addresses on the routers. And the thing is, there is no any predefined Anycast address, and they are defined per subnet. There are different methods that we can use to assign IP version 6 addresses to hosts. The first one is static configuration. Just like IP version 4, we assign IP version 6 manually on the computer or host. The next method is called SLAC, or stateless address auto configuration. With the SLAC, we use a method which is called modified EUI64 or just EUI64. I'll talk about it in a moment. The other way is stateful DHCP version 6, which is just like IP version 4. We create a DHCP server and we assign IP and other parameters to the hosts via a DHCP server. And the last one is called stateless DHCP version 6. In a stateless DHCP version 6, hosts get their IP addresses with the SLAC method and get the other parameters other than the IP, like TFTP server, NTP server, or whatever, from the DHCP server. Modified EUI64 or just EUI64 is a method that helps us to assign IP version 6 addresses automatically to the computers or hosts. EUI stands for Extended Unique Identifier. To be able to use EUI, our prefix should be 64. So we have the first 64 bits from the network design and we generate the next 64 bits from the MAC address. How? I show you in a tip. As I said, in EUI64, we need to generate the host part from the MAC address. But MAC address is only 48 bits. So we need more 16 bits to generate the host part, which is 64 bits. To do that, or in EUI64, we divide our MAC address in two different parts. First 6 characters in first part, and the next 6 characters in the second part, and then we inject FFFE in the middle of these two parts. So for example, if this is our MAC address and we divide it into separate parts, in two separate parts actually, and inject FFFE in the middle, the result would be the thing that you can see in this slide. But this is not the final result. As the next step, we have to invert the UL bit. UL bit, or universal local bit, is the 7th bit from the left of each MAC address, which determines the MAC address is universal or local. And whatever it is, we have to invert it. And then we will have the final result, as the one you can see in this slide. 0228 F8 FFFE 473749. Or based on the abbreviation rules, we can just remove the leading 0 from the first quartet. Alright guys, in today's video we covered the following CCNA topics. Compare IPv6 address types: global unicast, unique local, link local, anycast, multicast, and modified EUI64. I wish you enjoyed this video and thanks for watching.